Assalamualaikum warahmatullahi wabarakatuh. We will presenting about our group assignment, which is the title is simulation model. So my name is KHAIRIN WAFI. I would like to presenting about introduction and first question. So for introduction, simulation techniques help us make better decision by modeling real life situation. This document looks at three examples, which is AC compressor failures, car arrival, and heater sales. So this simulation use simple tools like probabilities and random numbers to predict outcomes. First is AC compressor failure. It's help plan maintenance and keep enough spare parts ready. Second is car arrival. It's help manage traffic and parking efficiently. And lastly is heater sales. It helps understand demand and avoid running out of stock. This simulation make it easier to predict results, solve problems, and improve planning in everyday situation. So next is question 1. So for the first column, which is number of AC compressor failure, this lists the possible number of compressor failure, which is from 0 to 6. The second column shows the probability of each number of failure. So the third column provide the cumulative probability, which adds up the probabilities from the start to that row. So how we get the cumulative probability, which is 0.06 at 0.13, we get a 0.19. So 0.19 at 0.25, we get 0.44. 0.44 at 0.28, we get 0.72. 0.72, we add 0.20, we get 0.92. 0.92, we add 0.07, we get 0.99. 0.99, we add 0.01, we get 1. So for the fourth column specifies the range of number corresponding to each failure count, which is random number interval. We get 0, 0 until 0.5. For the 0.6, 0.19, we get 0.6 until 8.18. For the 0.44, random interval number is 19 until 43. 0.72, random interval number is 44 until 71. 0.92, the random number interval is 72 until 91. Community probability, we get 0.99. So the random interval number is 92 until 98. So for the cumulative probability is 1. We get for random number interval 99 until 00. So for the next, a random number is generated by Excel. We using the Excel. And how we get a random number? So for the formula is equal rand between 0 until 99. So this number is matched to a range in the random interval number column to predict the number of failures. So this is our random number 25 until 65. Sorry. So for the formula, equal rand between 0 until 99. Okay, so that's all from my part. I would like to invite ADLIENA SYAHIRIEN to continue the question 1. So that's all from me.
Okay, thank you, Kairin, for your explanation just now. Assalamualaikum. My name is ADLIENA SYAHIRIEN, and I will continue for the next step on the question 1. So after you gain all the random numbers from the Excel, you need to create a new table that contains random number and the simulation, and you need to list down all the random numbers in the table. Since the question stated 20 years, then we need to list down all the 20 random numbers. After done list all the random numbers in the table, we need to find the numbers of the simulation for each random number. To get the value of simulation for each random number, we need to refer to the first table, this table, which is the random interval number and the number of AC compressor failure. So the first column and the last column of the first table. For example, since the first random number is 25, the first number, random number is 25, right? We need to figure which class is that number 25 is placed. So we need to refer the two column in the first table, and the simulation number for the random number 25 is 2, since it plays at the class number 2. Then repeat the same step until it done all the 20 random number. After done the simulation number part, we need to total all the simulation number to calculate the average value. This is the calculation. We just add all the simulation number, and the total that we get for the total simulation is 57. So we move to the next slide, which is calculate the average number and approximate value. In this part, we divide the total simulation with 20 years as it stated in the question. So 57 divided by 20, we get 2.85, that is equivalent to 3. Then the answers for the average value is 3 years. For the last step is calculate the approximate value. To count the approximate value, we need to multiply the value from the first column, from the first table, with the probability value for each row, and just add all of it. Then after we calculate both column and each row, we get 2.68, that is equivalent to 3. Then the answer is 3 years. That's all for the question number 1, and I will pass to my group mate to explain the second question. Thank you.
Hi, my name is AHMAD, and my ID student is 572121231994. So I will continue to present about question number 2A. So in question 2A, we must to set up the probability and cumulative probability distribution for the variable arrival car. So in order to find the probability, we will use a formula given below, which is frequency divided by total frequency. So for the total frequency, after we add all the number in the column frequency, we get the total is 200. So in order to calculate the probability, that is, for example, 0 divided by 200, we will get 0. 20 divided by 200, we will get 0.10. And 30 divided by 200, we will get 0.15. And 50 divided by 200, we will get 0.25. And 60 divided by 200, we will get 0.30. And 40 divided by 200, we will get 0.20. And last but not least is 0 divided by 200, we will get 0. So in order to make sure our probability is correct, after we add all the number in the probability column, we will get 1.00. So it's shown in our table, our probability is correct because the final answer, the total after we add all the amount, we will get 1.00. So now I will continue to explain about how to calculate the cumulative probability distribution. So cumulative probability distribution is we must add all the number row by row until the end of the row to get the cumulative probability. So for example, 0 add with 0.1, we will get 0.10. So 0.10 add with 0.15, we will get 0.25. 0.25 add with 0.25, we will get 0.50. 0.50 add with 0.30, we will get 0.80. So 0.80 plus with 0.20, we will get 1.00. And 1.00 add with 0, we will get 1.00. For the total, for the cumulative probability is 1.00. So this is the final answer for the probability and cumulative probability. So that's all from me. I will let other presenter to explain their part. Thank you.
Assalamualaikum and hello. My name is KAISAH KARMILA binti Muhammad ZAKI. Today I will explain about question 2 part B. The question is simulate 15 hours of car arrivals and compute the average number of arrivals per hour using random number 2 digit. So we need to do a table which is consists of numbers of car arriving, the probability, the cumulative probability and the random number range. So we have numbers of car arriving which is 3, 4, 5, 6, 7 and 8. And next we have the 15 random number here with the range and also the numbers of cars arriving based on the previous slide. Numbers of car arriving. So next we have the formula of average, which is sum of simulated arrivals divided by total number of hours. So we sum all of the numbers of car arriving and we get 84. So 84 divided by 15, which is the total number of hours based on the question, and we get 5.6. Then the approximately value, which is the numbers of car arriving in the slide 1, which is 3, 4, 5, 6, 7, and 8. We total it and we get 6.35 hours.
Hello, my name is Aisha. Today I will talk you through an analysis of heater sales using probability distributions, cumulative probabilities, and simulations. I will explore how these tools help predict stock out and inform supply decisions. Let's get started. For the step 1, which is probability distribution, we begin with the probability distribution of sales data. This is essentially likelihood of selling a certain number of heaters in a week. For instance, if sales were 3 heaters, it happens in 2 out of 100 weeks. Giving a probability of P bracket X equals 3 bracket equals 0.02. Similarly, for sales of 7 liters, it occurred in 25 weeks, resulting in P bracket X equals 7 bracket equals which is 0.25. The total probability as expected sums up to 1. This confirms that our probability distribution is valid. It's essential to understand this baseline before moving to simulation or cumulative probabilities. Next, for the step 2, cumulative probability distribution, we calculate cumulative probabilities. This tells us the probability of sales being less than or equal to specific number. For example, the cumulative probability for X equals 6 is 0.36, meaning there's a 36 chance of selling 6 or fewer heaters in a week. Similarly, for X equals 9, the cumulative probability is 0.85, meaning there's an 85% chance of selling 9 of or fewer heaters. This data also allow us to assign random numbers range to sales values. For instance, sales of 3 corresponded to random numbers 0, 0 to 01, sales of 4 to random numbers 02 to 10, and so on. This range are vital for our simulation steps. Next, we go to simulation setup. We We use this data to simulate sales for 20 weeks under 2 cases. Each week's sales were determined using random numbers mapped to the cumulative probability range. The supply was fixed at 8 liters per week. If demand exceeded supply, a stockout occurred. Next, we will review the case 1 simulation result. Out of 20 weeks, stockouts occurred in 7 weeks. Total sales were 139 liters, giving an average of 6.95 liters per week. For example, in week 1, a random numbers of 7 made to sales of 4 liters were below the supply, so there was no stockout. In week 2, a random number of 88 made to sales of 10 liters, exceeding the supply, resulting in a stockout. This pattern repeated across the weeks, contributing to the total stockout count of 7. Now let's look at case 2. Just like case 1, there were 7 weeks with stockouts. Total sales were slightly lower at 138 liters, averaging 6.90 liters per week. Again, stockout occurred when demand surpassed supply. For instance, in week 4, a random number of 18 made to sales of 9 liters, causing a stockout. In week 10, a random number of 34 made to sales of 6 liters, which was within supply, so no stockout occurred. To better understand stockouts, in case 1 weeks, like 2, 6, and 9 show sales greater than 8 liters, leading to stockouts. Similarly, in case 2 weeks, like 4, 7, and 14 had stockouts due to higher sales. Both cases highlight how sales spikes can disrupt supply and lead to missed opportunities if inventory isn't adjusted accordingly. Lastly, we calculated the expected value for weekly sales using the formula given by multiplying each sale value x by its probability p bracket x and summing the result. We found x 7 equals which is 7.16 liters per week. This means on average we can expect demand for about 7 liters weekly, which is a key input for supply chain planning. Simulation using probability distributions allow us to predict sales patterns and identify potential stockouts. Both cases show similar outcomes with 7 stockout weeks over 20 weeks. The expected value of 7.16 liters per week can help optimize inventory levels and minimize shortage. This approach ensures better decisions making for supply and demand management. For the conclusion, the simulations provide valuable insights into system performance and decision making. For AC compressor failures, the average failure rate is approximately 2.85 failures per year. For car arrivals, the average simulated arrival rate is about 5.6 cars per hour, matching the expected theoretical value of 6.35 cars per hour. Heater sales simulation yielded average weekly sales of 6.95 and 6.90 for 2 cases, with the new expected value estimate at 7.16 liters per week. Such analysis demonstrate the effectiveness of simulation in understanding probabilistic events and optimizing inventory and resource allocation. Thank you for your attention. I hope this detailed explanation clarified how probabilities, cumulative distributions, and simulation can be applied to real-world inventory challenges. Thank you.